it seems like we have a launch off. Let's go. All right, welcome to, I wanted to do a few little short videos on this Introduction to Chemistry, the second week, just to give you a couple of, things you can kind of focus on and maybe latch on to that you may be having some difficulty with. So this beginning of this part 4 talks about aqueous compounds. You're going to need to be able to evaluate whether a compound, an ionic compound in water, will either be aqueous, nice and dissolved, okay, interacting with water, or if it's just going to be undissolved, sitting at the bottom of your container. To do this, we use this table 8.8. So let's go ahead and talk about this. We're going to need this skill to figure out double replacement products and phase labels, okay? So how do we look at this table? Well, first and foremost, let me see if I can get my pen active here. By the way, my tablet is so sensitive, so hopefully I don't have to erase too much. So let me put these tables here. All right, so this table is divided into two sections. I just wrote them on there. Aqueous on the left and non-dissolved, sitting at the bottom of your container, non-aqueous basically, on the right. So I want us to look at how we read this. These ions over here on the left are aqueous. So that includes, I want to focus on lithium, sodium, potassium first because that's in group 1A. Also ammonium ion, NH4+, nitrate ion, NO3-, and this C2H3O2- is the acetate ion. These guys are always soluble, okay? These arrows in the middle lead you towards exceptions. So these guys are always soluble, and if you look, there's no arrow that takes it to the non-soluble side. So I call these my top dog girls. These ions are always soluble, okay? Also soluble are some of the halogens, mid-halogens, so chloride ion, bromide ion, iodide, okay? Soluble unless, follow the arrow, they become insoluble when they have silver ion, lead ion, and mercury ion. These, as compounds, as elements get larger and ions get larger and larger, like silver and lead and mercury and barium, it gets harder to keep them in solution. They're just too big. Another soluble ion is sulfate ion. It's generally soluble unless it's paired with this large barium ion, lead ion, calcium, and strontium ion. Okay, so your quest here when you look at a compound is to find the ions in the compound and look where they fall on this table. Okay, something could be soluble like a chloride ion, but if it's lead chloride, you're going to find out the lead is insoluble. So that makes the whole compound insoluble. So the top dog rules are here, group 1A, nitrate, ammonium ions, acetate, okay? When a substance dissolves, it actually interacts with water. Seawater getting in here and separating out the cation, which is the sodium ion, and the chloride anion. So it kind of gets around them and kind of hangs out with them. So that's kind of that's what happens when you dissolve. Here's an example of an insoluble compound. Now this isn't an ionic compound, it's oil, it's organic. But you can see there's two layers and there's no mixing. There's no interaction going on whatsoever. Okay, so I want to scroll down here to make sure you can use, and by the way, this question 3 has a cute little video there. I hope it works for you guys. I want us to use the solubility table to predict whether we see what we think will happen with a few of these compounds in water. So let's go ahead and evaluate question 4, which asks us to evaluate KCl in water. Okay, question A says, what do you expect to happen when KCl is in contact with water? And after you stir it, and it's a modest amount, it's not a huge amount, okay? You put it in there and you stir. Does it dissolve? Does it sit at the bottom? Which one? And is that resulting mixture, is it heterogeneous or homogeneous? And is KCl soluble in water? So maybe question C should be first. So let's go ahead and evaluate KCl, potassium chloride. I have the solubility at the very bottom here. KCl, so we are looking at two ions of interest. We are looking at KCl, which means I have K plus and Cl minus. Your job is to find them on the solubility table. Here's K plus, here's Cl minus. Both of those are on the soluble or aqueous side, right? So this compound, are you guessing it? It is aqueous. So let's go back over here. I'm going to say, is this aqueous means it is, Am I losing this? Equals, freezes up sometimes, so let me try to come back to it. Equals soluble. Okay, so this compound is soluble. If it's soluble, that means it's going to be dissolved. Okay, and of course if it's soluble and dissolved, you can't even tell the KCl is there, so it's going to be homogeneous. Okay, so let's go ahead and go look at let's go try question number 6, because I see this next one is lead 2 nitrate in water. I see the nitrate right here, and that's one of my, well, let's go ahead and do that one. Let's go to the solubility table, nitrates, okay. Where's my solubility table? Here it is. Let me clean it up again. If you're looking for lead 2 nitrate, let's figure out what ions there are. PbNO3, right? So that means I have Pb2 plus ion and NO3 minus ion. Okay, so if you're looking at it, I go find the lead 2 plus. Ooh, it's on the insoluble side. Okay, but I also see the nitrate ion over here. Okay, so even though the Pb2 plus is insoluble, okay, it will become soluble with NO3. So this makes this is soluble, and it makes the entire compound soluble. Okay, so if you're going back to things here, nitrate on any kind of ion means automatically soluble, okay, and automatically dissolved in water. So yes, it's dissolved in water, and it's going to be homogeneous. Let's try one more example, the last one we have here, and we're ending this. Calcium carbonate. This is what we're looking for. It's basically chalk. Calcium carbonate, solid. We're going to add that to water. Okay. Oh, it looks like I have a typo there. So let's go ahead and go to calcium carbonate. Let me see if I can clean this up. So what ions are we going to focus on now for calcium carbonate? Okay. Calcium carbonate. Okay, well, let's break it into ions. It means I have the calcium 2 plus ion and the carbonate 2 minus ion. So I'm going to go look for it. Here's the carbonate ion. Oh, it's insoluble unless, let's go explore the exception, unless it's paired up with, do I see calcium over here? No, so that means that this whole compound is insoluble. Okay, now what if sodium would have been on this? Sodium carbonate or lithium carbonate? It would have automatically been soluble. So this one over here, I'm sorry, this is a typo. So we definitely, CaCO3 is insoluble. Okay, insoluble, and it would be sitting at the bottom. Okay, and it would be heterogeneous. Okay, so here's that short video here. I hope this has helped you a bit to figure things out. All right, thank you.